Hello and welcome. Today we're diving into an overview focused on one of the most influential product safety standards out there for tech and electronics, IEC 62368-1, edition 2023, published by the International Electrotechnical Commission. There's a lot packed into this, right?
Absolutely. This standard really underpins the way a lot of our everyday electronic devices, from your speakers and smart TVs to complex communication infrastructure, are designed to keep people safe. And it's not just about meeting rules, it's about a shift in mindset to a much more hazard-based approach.
Right. Rather than just listing off do this, don't do that, the document actually emphasizes identifying possible harm, figuring out who's involved, and putting the right protections in place. So, we'll be covering everything from who this standard is for, the different types of risks for users and professionals, how pain or injuries can occur, and what to do about everything from shocks to burns.
And if you ever wondered who's really at risk when I plug something in, or how do they stop devices from starting fires or causing injuries in the first place? Well, you're in the right place. By the way, all our info is drawn directly from IEC 62368-1, copyright 2023.
All right, let's dig into the core principles of the standard, why it exists, what it hopes to achieve, and what makes it so central to anyone designing or using electronic equipment. So, at its core, IEC 62368-1 moves away from rigid, old school rules and focuses on a hazard based performance approach. Instead of saying, tape this wire exactly this way, it's all about spotting potential hazards, understanding how people might get hurt, and then picking the best ways to prevent that pain or injury. The main principle is on the systematic prevention of harm. It pushes for a structured risk based approach. Designers are expected to ask, what could cause pain or injury? And then, what's the most effective safeguard?
Sounds so much more flexible. But who exactly is the standard meant to protect? Like, are we talking only about end users?
Great question. There's actually a whole section on this. The standard classifies people into three main categories: ordinary persons, which is, most of us, the consumer; instructed persons, who've had some training, like a worker who knows the basics; and then skilled persons, the technicians or engineers who've got professional knowledge about risks and protective measures.
Interesting. So, like, even for maintenance crews or, say, someone installing a server rack, the safeguards and requirements might actually be different, depending on which group is exposed.
Exactly. And the standard spells out who is expected to interact with the equipment and how. Like, an ordinary person shouldn't be expected to recognize subtle hazards that only a skilled person would know. The protections have to match the experience level of the user.
That makes sense. And when it comes to how pain or injury happens, what's the model here?
The document actually breaks this down, too. First, there's recognition that pain and injury come from exposure to all sorts of energy: electrical, thermal, mechanical, even chemical or radiation. The model looks at both the likelihood and the severity. How easy is it for something to go wrong, and how bad can it get? It's a move to really understand both the probability and impact of harm.
Right. So the idea is not just protecting against the worst case scenario, but balancing between chance and outcome. That's actually pretty thoughtful.
Exactly. Then, once potential pain or injury models are built, the standard wants you to ask, where are all the energy sources within the product? Because energy is what causes these different kinds of injuries. So we're not just thinking about a zap from a faulty plug, but also burns, moving parts, chemicals that might leak, or even UV or IR radiation.
Huh. And that covers a lot more than, say, just worrying about shorts and fuses, right?
Definitely. The standard covers electric shock, fire, skin burns, cutting or pinching hazards, chemicals and hazardous substances, plus radiation. Each of these is categorized as a source of potential energy that could end up hurting someone if not properly managed.
So, how do you actually stop all that bad stuff from happening? What sorts of safeguards does this document recommend?
There's a really detailed breakdown. First, you've got equipment safeguards, mechanisms like protective housings or automatic cutoff features built right into the device. Then there are installation safeguards, like proper labeling, instructions, or even specific placement within an environment. There's also personal safeguards, like gloves or protective gear, and behavioral safeguards, things that rely on people's actions and habits, like following warning signs and instructions. And then, during service or maintenance, safeguards are adapted to who's present. For an ordinary person, access to dangerous parts is totally blocked. For a skilled person, safeguards might be instructions or tools given their experience.
Got it. So for each risk, like electric shock or fire, you actually match the level and type of safeguard to the kind of energy and the owner's expertise?
Exactly. For electric shock, there are insulation requirements, grounding instructions, and separation distances. For fires, there are rules about materials that can ignite or spread, for hazardous substances, safe containment, and labeling. Thermal burns, think automatic shutoff, surface temperature limits. Even mechanical and radiation injuries have physical barriers or training requirements.
That's comprehensive. And thinking about everything we use day to day, it's almost invisible how many layers of protection are involved, especially since none of this is like spelled out to consumers.
Absolutely. And, a lot of folks don't realize just how many types of injury are considered. For example, if you think about a simple laptop, safeguards exist for electric shock, battery fire, burns from overheating, even for leaking chemicals, or less common but possible, radiation from the screen.
Which leads me to a question for the audience. Have you ever thought about all the layers of protection that go into making your tech safe to use, or do you just kind of assume nothing can go wrong? It's worth pondering for a second.
The scope section of IEC 62368-1 spelled out that it's for audio, visual, or information and communication technology equipment. That includes everything from home theater systems, laptops, wireless routers, basically all the connected stuff in homes and workplaces. One thing I find interesting is the standard sets up boundaries. Like, it doesn't just tell you the maximum allowed voltage, but it considers how the equipment is used. Is it portable? Is it permanently installed? And adjusts requirements accordingly?
Oh, that part always kind of surprises me. It's not one size fits all. There's nuance depending on if something is in a hospital versus a home office.
Exactly. Because, say, in a hospital setting, there's just no room for error, right? The hazard based approach is about reducing the risk of fire, electric shock, even the smallest injuries by understanding the environment the equipment will actually be in.
Right. That makes me wonder, like for regular listeners, have you ever thought about the layers of safety between you and a spark from your TV? It's wild how much has to go right.
Most people probably don't, and that's kind of the point. Now, backing up a step, the document also lists what are called normative references. In plain English, these are other standards you must check out or apply for your gear to actually comply.
Right. It's like a web of compatibility. One standard might reference another about, say, flammability, so you can't really pick and choose. You need the whole ecosystem to work.
Exactly. And if you're wondering why, well, if definitions and requirements in different standards don't align, it's chaos for manufacturing and regulatory checks.
It's like, imagine if every country had a totally different definition for dangerous voltage. You'd never know if your phone charger is actually safe when you travel.
Yes, that's exactly it. IEC 62368-1 doesn't work alone. Now, probably the hardest section for a lot of people is the terms, definitions, and abbreviations. But honestly, this is where a lot of the magic happens, especially for engineers. I want to start with energy source abbreviated terms. There are shorthand codes like ES for energy source and ES1 or ES2, which define how hazardous an energy source is. ES1 might be low enough to not cause harm, while ES3 could be definitely risky.
So every time someone says ES2, I should be thinking moderate risk, but not the worst possible hazard.
Right, but it depends on things like access to the part of the equipment, user behavior, and what kind of safeguards are in place. That's a term that reoccurs. Safeguards, meaning the barriers or warning systems that protect users. Beyond energy, there are so many other abbreviated terms. FIW, that's for functional insulation wire, AV for audio video, ICT for information and communication technology, and so on. It's an alphabet soup, but it all matters because missing a single definition can throw off entire compliance plans.
I had no idea FIW meant that. And there's a whole bunch more in the standard, right?
Oh, yeah, lots. For example, we get into circuit terms like protective earth conductor, enclosure terms that describe the outer shell, specific equipment terms, definitions about flammability, electrical insulation, potential ignition sources. It's all there, and each has a precise meaning to avoid confusion.
And that's important because, like, let's say you misunderstand what qualifies as a potential ignition source, that could lead to totally missing a key hazard.
Absolutely. And there are sections on ratings like maximum safe voltages and currents, classes of equipment based on electric shock protection, terms related to batteries, and even sound exposure, which is especially relevant for modern, loud gadgets.
Right. And people sometimes forget even audio exposure gets its own safety criteria. Do you think listeners realize how detailed this all gets?
Probably not, but that's why this standard is so foundational. We've looked at how the scope, the references, and the definitions all work together to make safety a practical reality in our devices.
Definitely. If you design products or just want a safer home, understanding these frameworks is key. And even if you're not in the industry, it's kind of reassuring, right?
For sure, and as technology keeps evolving, these standards will too. I guess the next time someone plugs in a device, maybe they'll spare a thought for all the safeguards built in thanks to documents like IEC 62368-1.
If you're curious about how to keep up with these standards or make your products compliant, we'd suggest always starting with those definitions because getting terminology right is really the first safe step.
Thanks for joining us for this safety deep dive.